The last section of the natural world paper will always be on fieldwork. This section will include questions about coasts and rivers. It is very important, therefore, that you learn exactly where we went and what we did. It is important that you can remember where we went to study, which was looking at the River Lynn in Bradgate Park, Leicestershire. The map shows part of the park. We studied between points 1 and 2, as you can see on the map. It is also vital you remember why we went, which was to answer, is the River Lynn a typical example of an upper course stream? In order to answer this, we will use the Bradshaw Model. This model shows what is generally expected to happen to a river over its course from the source upstream, shown on the left of the diagram, as its source flows downstream towards its mouth. The results from our fieldwork should match up with the left of the model, such as a very small discharge, or a large load particle size, or large channel bed roughness. During the day we looked at these 4 key questions, which should help us show that the River Lynn matches up with a typical example of an upper course stream, similar to what the Bradshaw Model shows. You need to at least remember one of these key questions and points here. This image shows us one of the fieldwork surveys we carried out. You will need to recall the tasks we did and the methodology, which basically means how we went about getting the results. One of the surveys we looked at was velocity, the speed of the water, by using range poles 10 metres apart, a stopwatch and a float. We recorded how long it took the dog biscuits to travel the 10 metres and then repeated the process several times so that we could get an average set of results. They may also ask you to complete either the drawing of a graph or to explain the style of graph you drew and why. For the velocity of the river, we drew a line graph showing the different sites along the bottom and time up the y-axis. We then plotted a line graph to link up the results. We chose a line graph because it's continuous data showing data changes over time or space. We could then compare our results to the Bradshaw model to see if our data matched up with what was expected. The examiners may also ask about any issues or problems that we had whilst gathering the data. Remember, for this measuring the velocity, we came across several problems, such as the water level being too low that the dog biscuit got stuck. Large rocks within the rough river channel also kept trapping the dog biscuits, which spoiled its direction and flow on our results. And over time, the dog biscuits started to break up and not float properly. They may also want us to evaluate the results and see and think about how they could be improved. Had we used a flow meter, such as the thing you can see in the picture, then we could have had a lot more accurate results than what we got. A top student will also be expected to be able to remember some of the other surveys that we carried out on the day as well, and be able to say why we carried out these surveys. We would also need to remember what equipment and tasks we did, how we graphed the results, and then be able to evaluate the results and mention any problems we came across whilst linking our results to the Bradshaw model. One of the other surveys you could also refer to was the Lert Sample. This was where we collected the rocks and worked out how angular they were compared to both the Kalo index and the Bradshaw model, as well as measuring their diameter with a ruler or perhaps even with a caliper. It is vital that you are able to recall and understand our fieldwork findings and how they relate to the Bradshaw model throughout. Hopefully this show will refresh your memory and help you to be ready to answer whatever the exam throws at you.